Hello, everyone. I just wanted to record a video giving you tips for how to use Table G to answer Regents questions or Regents style questions about solubility curves. So as a brief reminder, what I'm showing you right now are our notes from Tuesday about solubility curves. Just remember the word soluble means able to dissolve, while the word solubility is talking about how much solute can dissolve at a given temperature. So solubility is a number, it's an amount. And the other thing is that when you look at a solubility curve, the line represents where the solution is saturated at that temperature. So any point along this line represents saturated, which means anything under the line is unsaturated, anything over the line is supersaturated. So this is the most basic solubility curve. It has the solubility of just one substance on it, in this case KNO3. As you increase the temperature, more and more and more solute can dissolve. Our classwork yesterday had two lines on it, one for salt and one for sugar, and it showed that sugar was much more soluble than salt. We found that at room temperature, it was like 4 times the amount of sugar could dissolve as salt. And sugar is more affected by the temperature. That solubility increases greatly as the temperature increases. Salt, not so much. So table G is going to be like this, just a little bit more complicated. Now, I was originally going to give you another copy of the reference tables, but I decided I'm not going to do it because you already have it in 2 different places. So just as a reminder, in the course document section of Google Classroom, right here, chemistry reference tables, that's one place you can find it. You can also find it on the front page as part of the announcement, part of the, well, this is not your class, but here, I'll show you. I'm not lying. Your class too, 3rd block. Chemistry reference tables right there. Or you could literally Google chemistry reference tables and click on the first link. However you do it, you're going to get a copy of the reference tables and you're going to scroll down from the front page to table G, solubility curves at standard pressure. And standard pressure just means under normal conditions. And you see this solubility curve diagram is a bit more complicated. It has like 10 different substances on it instead of 1 or 2, but it works the same way. It has the same scale on the sides, solubility, remember, which is just how much dissolves. And that is grams of solute per, once again, 100 grams of water. This is just like yesterday, where the base, the reference amount of water is 100 grams. And all the questions we're doing today use 100 grams of water. We'll talk on Thursday about how they try to trick you with different amounts of water. But so for now, that 100 grams of water is just extra information in the question. And down along the x-axis, we have the temperature. And so for a lot of these, like sometimes it'll matter and you'll have to look at all the lines and all the substances. And for other questions, you're gonna like block out all the lines except for one. So I came up with 3 sample style questions just to get you going. And with this, you should be able to answer any of the questions on today's assignment. So here's practice one. Number 1, which substance is the least soluble in 100 grams of water at 90 degrees Celsius? So first of all, this 100 grams of Celsius, that's just saying normal conditions. You don't have to do anything weird with it. When you see least soluble, remember soluble means able to dissolve. So least soluble means which dissolves the least at 90 degrees. So when we look over here on the table, we go over to 90 degrees. The substance that's the lowest is SO2, sulfur dioxide. And that's it. That would be the answer. Another kind of question you might be asked. for which substance does 73 grams of solute make a saturated solution at 90 degrees? So before I even look over here at the table, I'm gonna notice this keyword saturated, and I'm gonna think back to the notes, and I'm gonna think saturated means on the line. So they give me a point. They give me two pieces of information. They give me an amount and they give me a temperature. So if I can find that point, whatever line it's on, that's saturated. So I go up to 73 grams and I go over all the way to 90 degrees, and that's right here. And it's right on the line for NH4Cl, which means that amount of NH4Cl at 90 degrees is the perfect amount to make it saturated. So NH4Cl is the answer for that. One other way it might be asked, 60 grams of HCl are dissolved in 100 milliliters of water at 20 degrees Celsius. What type of solution? No, what type of solution is made? Ignore that S. I don't know why I can't get rid of it. All right, so once again, this 100 milliliters of water, that's just extra information. That's them telling me you can use this table like normal. You don't have to do anything weird with it. So I've got two pieces of information, 60 grams and 20 degrees. Once again, they've given me a point. 60 grams, 20 degrees is right here. And they're asking me in a question about HCl. So I'm gonna ignore every other line except for the HCl line. And this is the part where if you don't have a paper copy, it gets a little bit difficult. Take your time. Yeah, like if you have a way of printing something, print out your own copy so you can like highlight stuff or shade stuff. But in general, find the HCl line, which is this one here, and then ignore every other line. This question's not about those other lines, so just ignore them. So 60 grams, 20 degrees right here is underneath the line for HCl. The line for HCl at this temperature is up here, but we're down here. So since we're under that line, this is an unsaturated solution. If we were on the line, it'd be saturated. If we were over it, it would be supersaturated. So those are the three example problems, the kinds of things you might be asked. Just remember, if a question is asking you about solubility, it's talking about how much dissolved. Is it high solubility, like this stuff up here? Or is it more low solubility, like this stuff down here? If a question asks you for the trend, that's another way of asking you the pattern. So what is the pattern in solubility for most substances as you increase the temperature? What does the solubility do, AKA the amount? I don't think like one at a time, any one of these questions is difficult. I just think it could be a little tricky, especially if you're not comfortable with the vocabulary. So have those notes open, have like this handy, look at it, have your reference tables handy, take your time, and good luck. I'll see you on Thursday.